This is activity 4, Intercepted, for lesson 13, more solutions to linear equations. And the reason that this activity is called Intercepted is because you're going to look at both the x-intercept, which is -2, 0, and the y-intercept, which is 0, -6. So you're supposed to plot these 2 points on this graph, draw the line, draw the graph, and see if this equation is the correct equation for that graph. Now, let's go ahead and look at the graph first. So this is the point -2, 0 is right here, and 0, -6 is right here. So this is the y-intercept, it's where it crosses the y-axis, and this is the x-intercept, where the line crosses the x-axis. And so we could just put these 2 points into this equation and see if they are solutions for this equation. But rather than do that, let's write the equation for this line and see if this is what we get. So first of all, let's figure out the slope. And the slope is how much this line changes in the vertical direction. So it changes 6 units in the vertical direction. So that's a -6 minus 0. This -6 right here minus this 0 gives you this change of -6 units. And it changes a +2 units in the horizontal direction. So this is 0 minus a -2. Remember, you're going to use the inverse operation and the additive inverse. So you're going to add a +2. So 0 minus a -2 actually equals a +2. So it's changing a +2 units in the horizontal direction. So that slope then is the change in the vertical direction, which is -6, over the change in the horizontal direction, which is +2. And then to simplify this, you can factor out the 2. So 2 times -3 divided by 2. These 2's, 2 divided by 2 is 1, so they cancel out. And so you're left with -3. So the slope of this line is -3, and that makes sense. If you go 1 unit in the positive direction, it's -3 units. 1 unit, -3 units. If it's 2 units, that's going to be -6. Or you could go the other way, a -1 unit, +3. So that's still a slope of -3. It's -1, +3. So it's a +3 over -1. But that equals -3. So -1, +3, +1, -3. Those are all the same, all a slope of -3. All right, so let's get this equation, or actually now we can write the equation. So the y-intercept is -6, the slope is -3. So now we can write the equation using the slope-intercept form. So we know that the slope is -3, so that's a -3x. We know that the y-intercept is -6, so this is going to be a -3x plus -6. So this is one form of the equation. This is the slope-intercept form, y equals mx plus b. But this equation is in the standard form. This is the ax plus by equals c form. So let's write this equation in this form, the standard form, and see if we get the same thing. It looks like we're going to, but let's do it and see what happens. All right, the standard form. 3x plus y equals -6. What I did is I added a +3x to this side to make this 0. And then I'm going to add that +3x over here. So this is going to become 3x plus y equals -6. So basically I'm moving this -3x over to this side. So that becomes a +3x. So 3x plus y equals -6. So this is now in the standard form, ax plus by equals c. And remember that the number that goes next to this y is a 1. This is 1y. So 3x plus 1y equals -6. But this equation up here is 3x. And what I'm going to do, First of all, let's just add a couple more lines, a couple more points, so we can extend the line. A couple ways to do that. One way to do that is just to use x as positive 2 and see what we get for y. So take this equation, use this equation right here. So negative 3 times positive 2 is negative 6. Negative 6 plus negative 6 is negative 12. So this is going to go out 2 units and then down 12 units. So this point right here. And then let's use negative 5 as an x value and see what we get for y. So negative 5. So negative 3 times negative 5 is a positive 15. A positive 15 plus negative 6 is positive 9. So this is negative 5, 9. So you go out here to negative 5 and go up to 9. And both of those points are on this line. So that further confirms that this is the correct equation for this line. All right, and I can't remember if I said this or not, but here's positive 2 and negative 6 for the slope, and that slope is negative 3. All right, now I'm going to rewrite this equation. Actually, if you rewrote this equation by adding a negative y, so you're going to use the inverse operation of addition, and the additive inverse of a positive y is negative y, so you're going to add a negative y. But this equation down here is 3x plus a positive y. So they don't match. It's a different equation. So the answer is no, that this is not the equation for this line. Well, let's continue with this, and let's draw the line for this equation. We should get something different than this line. So I'm going to go back to, this is the standard form of the equation for this line. And remember, this is a nice way to figure out both the x and y-intercept. If we make x 0, y equals negative 6. So x is 0, y equals negative 6. And if we make y 0, you get 3x equals negative 6. And that means that x is equal to negative 2. Negative 6 divided by that 3 is negative 2. So if we make y 0, then we get x equals negative 2. So the x-intercept is negative 2, 0. Y-intercept is 0, negative 6. So all I did is kept the same line as before and confirmed that these 2 points are solutions to this equation. And these are the 2 points we started with. They're up here. This is the x-intercept and this is the y-intercept. All right, so now let's draw the graph of this equation right here. So I'm going to write this equation right here, 3x minus y equals negative 6. So now I'm going to add the additive inverse. This is minus a positive y. So I'm going to add the additive inverse. The additive inverse of a positive y is negative y. So this equation now is 3x plus negative y equals negative 6. And so now I'm going to use this form to figure out what the y-intercept is and what the x-intercept is. So if x is 0, what's y? So this is figuring out what the y-intercept is. So let's make x 0. So where does it cross the y-axis? Well, if x is 0, 3 times 0 is 0, and you get negative y equals negative 6. Well, that's kind of weird. Negative y equals negative 6. Well, take the opposite of a negative y. So the opposite of negative y, that's going to equal the opposite of negative 6. So once again, the opposite of negative y is going to equal the opposite of negative 6. That means that y equals positive 6. So the y-intercept is 0, positive 6. It's right here. So 0, positive 6. The x-intercept, what happens when you make y 0? So I'm going to make y 0. So where does it cross the x-axis? So y is 0. So where it crosses the x-axis is the x-intercept. So y is 0. So let's use this equation right here. So y is 0. So we're left with 3x equals negative 6. What's x equal? That equals -2. So the x-intercept is -2, 0. Well, look at that. That's the same point as the equation down here. So this point is shared by both lines, and it's a solution to both equations. So let's connect those points. So this is the line for this equation. This is the line for this equation down here. So the equations are different. And let's extend this line out a little bit farther. So we can do that by choosing x equals -4. So if we do that, x equals -4, so 3 times -4 is -12. So it's -12 plus a negative y. That equals -6. So if you add 12 to both sides, so I'm going to use the additive inverse of -12, +12, I'm going to add +12 to this side. A +12 plus a -6 is +6. This becomes a -y equals +6. And the opposite of a -y is +y, and the opposite of a +6 is a -6. So y equals -6. So this point, -4, -6, is graphed right here, -4, -6. And so that confirms that we did the calculation correctly because it is on this line. So this is the line for this equation. This is the line for this equation down here. So long way of saying that the answer is no. This equation does not match this line. It's not the equation for this line.